Hey guys, this is 4.3, the definite integral. Go ahead and try the warm-up. We have some one-sided limits on the top, and then number 2 is a derivative, and you're evaluating it at certain points. All right, so number 1, we're looking at a limit of 1 over x squared minus 4, and we're approaching it from 2 and negative 2, both from the right and from the left. Okay, so let's start by looking at 2 from the right. So if you recall, here's, 2 on your number line. You're actually coming towards 2 from the right, which means you're a little bit above 2. So what that means is on the bottom, when you square that number, you're actually going to be a little bit above 4. So when you subtract 4 from that, you are a little bit above 0, and this gives you positive infinity. Okay, for a little bit below 2, which is 2 from the left, okay, now I'm coming from the left. So when I square that, I'm going to get close to 4, but a little bit less than 4, which gives me a little bit less than 0 when I subtract 4 from it, so that would be negative infinity. Okay, the next one is negative 2 from the right. So that is going to be, when I square it, a little bit less than 4. Minusing 4, I get a little bit less than 0. So this gives me negative infinity. And then negative 2 from the left, I'm actually at like negative 2 point whatever. That when I square that, I'm going to get a little bit more than 4. Subtracting 4 from that, I get 0 positive, which is positive infinity. Okay, for number 2, the first thing we want to do is actually find the derivative of f. So let me do that down here. So this would be using the chain rule, 1/2, 2x plus 1 to the negative 1/2 times the derivative of the inside, which is 2. You'll probably notice here the 2 and the half are going to cancel. So this just gives me 1 over the square root of 2x plus 1. All right, let's plug in 0. That's going to give me 1 over the square root of 1, which is 1. Plugging in 1, I'm going to get 1 over the square root of 3. Plugging in a half, I'm going to get 1 over the square root of 2. And plugging in 4, I'm going to get 1/3. All right, so today we are starting definite integrals. And this is one of my favorite things in Calc 1, and it's mostly what we focus on in Calc 2 is integrals. So today, the only difference from what we did in 3.13 is that we're actually going to have a lower limit and upper limit on our integral here. And all that means is that we're actually going to have numbers to plug in at the end, and we're not going to have a c. All right, so let's look here. In the last lesson, we learned about Riemann sums. In this lesson, we will learn about the idea of the definite integral. That is, as the width of the rectangles of a Riemann sum approach 0, the corresponding sum approaches a limiting value j. So the definite integral is actually the Riemann sum, where the limit of n goes to 0, meaning the width of the rectangles gets super, super small, and the area under the curve becomes very exact. Okay, so the way that we speak this right here is the integral from a to b of f of x with respect to x. So the dx is just telling us what's our independent variable. And here we have little definitions here. We have our lower limit a, upper limit b. That's our integral sign there. And then we have our function that we're integrating, and then our variable of integration, or our independent variable. Okay, so a couple of rules that are handy to keep into mind. So number 1 is your order of integration. So here we have the integral from a to b. If we wanted it to make the integral from b to a, we would just negate the final answer. Number 2, if we integrate from a to a, the answer is 0. And that makes sense because if we have a curve and here's a, if we're just not going anywhere, then there's no area under that curve, right? If we're not moving at all. Next is constant multiple, and this just says that if we have a constant in here, we are allowed to pull it out. And then at the end, we can just multiply our final answer by that constant. Number 4, sum or difference, is saying we can actually split up our integral into 2 integrals and then add the answers at the end or subtract them. And number 5, additivity. So here we have A to B, B to C. And this is saying instead of adding those, we could actually just go from A to C and it would be the same answer. Okay, so we're going to use those rules to try number 1. So number 1 is they're actually going to give us some information here. So they're telling us the integral from 1 to 2 of f of x dx is -4. The integral from 1 to 5 of f of x dx is 6. And the integral of 1 to 5 of g of x dx is 8. Okay, so let's look at A. So A is the integral from 2 to 2 of g of x. And you should be thinking about rule number 2 from above. If we go from A to A, the answer is 0, so 2 to 2. Those are the same numbers, so our answer for A is 0. Okay, let's go to B. For B, we're going from 1 to 2, 3 f of x dx. So this is the rule number 3, where we're allowed to pull out the constant. So the 3 can come out. And here, I just have the integral of f of x dx from 1 to 2, which above I know is -4. So this is going to be 3 times -4, which is -12. Okay, C, we have a subtraction. So this is rule number 4 from above. And this just says that if you are subtracting, we're allowed to split this into 2 separate integrals. So I'm going to do that. Okay, so this would give me 6 minus 8, which is -2. Okay, let's go to D. Notice on D, this is exactly like this, except the 1 and the 5 are switched. So that is the rule number 1 from above. So instead of the answer being 8, it's going to be -8. Okay, on E, we're going from 2 to 5 of f of x dx. So we don't have that information, but we do know 1 to 2 and 1 to 5. So what we can actually do is we could do 1 to 5, and we can subtract off the 1 to 2, and that would actually give me the 2 to 5. Okay, so this is going to give me 6 minus -4, which is 10. Okay, and then the last one, we have 1 to 5 of 4 f of x minus g of x. So we're actually going to use both rules 3 and 4 from above. And so what we're going to do here is we're going to take the 4 out. And we're going to also separate our integrals. Okay, so this would be 4 times 6 minus 8, 24 minus 8, which is 16. All right, so that was just using the rules above. Similar situation on number 2. So they're telling us that the integral from 1 to 2 of f of x dx is 5. Okay, so now we're going to find all of these answers here. Now notice that they have changed the variable. That actually does not affect anything that we're trying to do, okay? So you are allowed to change the variable. It's still the function f. They're just using a different variable. Okay, no big deal. All right, so let's look at A. So 1 to 2 of f of u du. So since nothing has really changed except for the u, and we're plugging in all these numbers, the answer is still going to be 5. All right, let's look at B. So B, integral from 2 to 1 of f of t dt. Again, the t and the x shouldn't really bother you. Don't worry about that. But I do notice that instead of going from 1 to 2, I'm going from 2 to 1. So that's rule number 1 up above. So the answer here would be -5. All right, let's go to C. C, we have a constant multiple. So we have a radical 3 inside the function there. And so what I need to do on that one is just pull that out. So radical 3, and then I just have my integral from 1 to 2, f of z dz. And remember what I told you, the letter doesn't matter. So this would just be radical 3 times 5, or we could write it as 5 radical 3. Okay, and then the last one, we have 1 to 2 of negative f of x dx. Well, guess what? A negative is really a negative 1. I can actually pull that out as a constant multiple, and this is just like c. So instead of getting an answer of 5, I get an answer of negative 1 times 5, which is negative 5. All right, last one here, example 3. We have the integral from 0 to 3, f of z dz equals 3. The integral from 0 to 4, f of z dz is 7. Okay, so let's look at the first one. They want us to go from 3 to 4. So what I'm going to do is I'm going to go 0 to 4 minus 0 to 3. And that will give me just the 3 to the 4 that I want. So this would be 7 minus 3, which is 4. And then on B, they want us to go from 4 to 3. I can actually use my answer from A. Since this is reversed, my answer instead of positive 4 will just be negative 4. All right, so you guys have this page of homework right here. It's very similar to what we just did on the notes. I don't think you're going to have any issues with that. And after the Riemann sums lesson, which I'm anticipating was slightly more difficult for you, I'm sure that 4.3 is a welcome sites. All right, we'll talk to you guys soon.